This is the schematic for the audio amplifier portion of our project. This amplifier is based around two 1458 dual operational amplifier IC chips. We're going to assume you know a basic amount about circuits and op amps in this tutorial. The first chip acts as an inverting amplifier for two channels, input left and input right. It uses two 10 kilo ohm potentiometers as feedback resistors, one for each channel, to adjust the gain of the input signal. Using inverting amplifiers makes our output voltage negative rather than positive, but it allows us to trim our gain from 10 times the input all the way down to 0, which we couldn't do with non-inverting amplifiers. To switch the output voltage back to a positive signal, we use the second pair of op amps and make another inverting amplifier. Instead of using potentiometers on this chip, we use resistors of equal values so that there is no effect on the gain. To power our 1458 chips, we need positive and negative source voltage, and it needs to be able to run off a single 9-volt battery. Conveniently, we don't need much more than 50 millivolts, so we can make a simple voltage divider that will output positive 4.5 and negative 4.5 volts. We can do this simply with two 470 microfarad capacitors to keep the voltage constant and equal, and two 4.7 kilo ohm resistors to divide the voltage and give us our positive 4.5 volts, negative 4.5 volts, and a common.
For the VU side of the circuit, we use two LM3915N chips and 20 LEDs. This is the datasheet for the display driver chip, and it shows how the LEDs are integrated to each pin of the chip. Pins 4 and 5 are the inputs from the audio boosting circuit. The leads are tapped into on the output channels of that circuit. Pins 1 and 10 through 18 are linked to each LED. Pins 6 through 8 use a basic voltage divider to set the scale in which the LEDs will respond. Pins 2 and 3 are the power inputs, and to complete this as a stereograph, we had to complete the same circuit twice using the outputs of each channel from the audio booster to pin 5 on each chip respectively. As always, we breadboarded the circuit first to test the operation.
This is the enclosure that we designed using plexiglass.
This is the completed VU circuit on printed circuit board that was purchased at Radio Shack. The PCB board made soldering the IC chips much easier than plain perforated board.
The same style of board was used for the audio boosting side of the circuit.
This is the completed circuit unpackaged in operation. As you can see, each channel it's gain is controlled separately using potentiometers.
And this is the final completed circuit packaged and in operation.